Hello students, I am Mohammad Rizwan. Today we are going to learn exponents and powers. Children, have you ever seen a number given as the superscript of another number? At first, it can be confusing for the students to understand what exactly it is and what it signifies. Well, the concept of exponents is what is being employed in this case. When there is a situation where one needs to present a large number, it is condensed and written in the form of exponents, making it easier to write and remember. In many countries, exponents are called indices. But the good news is that the concept is the same no matter what term is used. When we have to repeatedly multiply a number by itself, we raise it to the power. This is known as exponent. The power in the exponent represents the number of times that we want to multiply the exact number. Exponents have their own set of rules when it comes to carrying out arithmetic operations. In this chapter, we will learn about powers, exponents, and their peripheral rules. Learning outcomes. After completion of this lesson, you will be able to know to express numbers in exponential form, to know powers with positive exponents, to know powers with zero and negative exponents, to understand the expanded form of numbers using exponents. Keywords from this lesson: positive numbers, negative numbers, addition, product, laws, integers, scientific notation, powers, exponents. Children, we use the word exponentially to describe something that sees a very drastic change. Exponents mean that the number is multiplied by itself multiple times. X raised to y means that x is multiplied by itself y times. We know that 10 plus 10 plus 10 plus 10 plus 10 is equal to 50. Whereas 10 multiplied 5 times is equal to 1 lakh. So, we have taken both these as the two equations. Equation 1 can also be written as 10 when added 5 times is equal to 5 into 10 and read as 5 times 10. Whereas equation 2 is also written as 10 multiplied 5 times is equal to 10 to the power of 5 and read as 10 raised to the power of 5. In 10 to the power of 5, 10 is called the base and 5 is the exponent or index or power. 10 to the power of 5 is called the exponential form or power notation of 1 followed by 5 zeros. Similarly, 11 plus 11 plus 11 is equal to 3 into 11, read as 3 times 11, and 11 multiplied 3 times is equal to 11 to the power of 3, which is nothing but 1331 and is read as 11 raised to the power of 3. In 11 to the power of 3, 11 is called the base and 3 is the exponent. In general, if x is an integer, then n times the product of x with itself is given as x into x into x, and so on, n times, and is denoted as x to the power of n. Here x is called the base and n is the exponent or the power or the index. X to the power of n is equal to product of n factors each of which is x. For example, 7 to the power of 6 is equal to 7 multiplied 6 times. Children, let us see powers with positive exponents. The value of powers given by positive whole number exponents quite often increases rapidly. Observe the following example. 2 to the power of 1 is equal to 2. 2 to the power of 2 is equal to 2 into 2 is equal to 4. 2 cube is equal to 2 into 2 into 2 is equal to 8. 2 to the power of 4 is equal to 2 multiplied 4 times, which is equal to 16. 2 to the power of 5 is equal to 2 multiplied 5 times, is equal to 32. 2 to the power of 6 is equal to 2 multiplied 6 times, which is equal to 64. 2 to the power of 7 is equal to 2 multiplied 7 times, which is equal to 128. 2 to the power of 8 is equal to 2 multiplied 8 times, which is equal to 256. 2 to the power of 9 is equal to 2 multiplied 9 times, which is equal to 512. 2 to the power of 10 is equal to 2 multiplied 10 times, which is equal to 1024. At this rate of increase, what do you think 2 to the power of 100 will be? 2 to the power of 100 is equal to 12676 and so on. Thus, we understand that the positive exponential notation with positive power could be useful when we come across large numbers. Now, let us see powers with 0 and negative exponents. Observe this pattern. 2 to the power of 5 is equal to 32. 2 to the power of 4 is equal to 16. 2 to the power of 3 is equal to 8. 2 to the power of 2 is equal to 4. 2 to the power of 1 is equal to 2. And 2 to the power of 0, what is it? Starting from the beginning, what happens in the successive steps? We find that the result is half of that of the previous step. So, what can we say about 2 to the power of 0? If we prepare a table like this for 3 to the power of 5, 3 to the power of 4, 3 to the power of 3 and so on, what will it tell us about 3 to the power of 0? We can use the same process as in this pattern to conclude that any non-zero number raised to the 0 exponents must result in 1. Thus, a to the power of 0 is equal to 1 where a is not equal to 0. Let us see what happens if we extend the above pattern further downward. As before, starting from the beginning, in the successive steps, we find that the result is half of that of the previous step. Since 2 to the power of 0 is equal to 1, the next step is 2 to the power of minus 1 whose value is a previous step's value 1 divided by 2, that is 1 by 2. Next is 2 to the power of minus 2, which is the same as 1 by 2 divided by 2, that is 1 by 4, and so on. Thus, 2 to the power of 3 is equal to 8, 2 to the power of 2 is equal to 4, 2 to the power of 1 is equal to 2, 2 to the power of 0 is equal to 1, and 2 to the power of minus 1 is equal to 1 by 2, and 2 to the power of minus 2 is equal to 1 by 4, and 2 to the power of minus 3 is equal to 1 by 8. In general, a to the power of minus m is equal to 1 by a to the power of m, where m is an integer. The expanded form of numbers using exponents. In the lower classes, we learned how to write a whole number in the expanded form. For example, 5832 is equal to, when expanded, 5 into 1000, 8 into 100, and 3 into 10 plus 2 into 1. So now, putting this in an exponential form, 5 into 1000 can be written as 10 to the power of 3 into 8 into 100 can be written as 10 to the power of 2 plus 3 into 10 is written as 10 to the power of 1 plus 2 into 1 is 2. Thus, 58.32 is equal to 50 plus 8 plus 3 by 10 plus 2 by 100. Which is 5 into 10 plus 8 into 1 plus 3 into 1 by 10 plus 2 into 1 by 100. Writing this in an exponential form, 5 into 10 to the power of 1 plus 8 into 10 to the power of 0 plus 3 into 10 to the power of minus 1. We bring the 10 upwards, and 2 into 10 to the power of minus 2. Let us see some more examples. Expand the following numbers using exponents. First one, 8120. How can we expand? From the thousandth term, we have 8 into 1000 plus 1 into 100 plus 2 into 10 plus 0 into 1. So we can write this in the exponential form as 1000 written as 10 to the power of 3 plus 1 into 100 written as 10 to the power of 2 and 10 written as 10 to the power of 1 plus 0. Next, we have 20305. We expand this, and next we see 10,000 can be written as 10 to the power of 4. So that is exponential form, 2 into 10 to the power of 4, and 0 into 1000 is 0 plus 3 into 100 written in the exponential form is 3 into 10 to the power of 2 plus 5 into 1 written as 5. Similarly, we can write another problem which is 3652.01. We expand this, now next we write this in the exponential form. We divide it, 3 into 1000 6 into 100, 5 into 10 plus 2 into 1 plus 1 into 1 by 100. 0 by 10 is 0. We write this in the exponential form. 3 into 10 to the power of 3 plus 6 into 10 to the power of 2 plus 5 into 10 to the power of 1 plus 2. 1 into 1 by 100, we write this in the exponential form as 1 into 10 to the power of minus 2. And the last, we have 9426.521. Let's expand it. 9 into 1000 plus 4 into 100 plus 2 into 10 plus 6 into 1 plus 5 by 10 plus 2 by 100 plus 1 by 1000. Next, we write this in the exponential form where 9 into 1000 can be written as 9 into 10 to the power of 3. 4 into 100 can be written as 4 into 10 to the power of 2 plus 2 into 10 can be written as 2 into 10 to the power of 1 plus 6 into 1 is 6 plus 5 by 10 can be written as 5 into 10 to the power of minus 1 plus 2 into 10 to the power of minus 2 plus 1 into 10 to the power of minus 3. Points to remember. An expression that represents repeated multiplication of the same factor is called a power. The exponent corresponds to the number of times the base is used as a factor. The positive exponential notation with positive power could be useful when we come across large numbers. A to the power of minus m is equal to 1 by a to the power of m, where m is an integer. Any non-zero number raised to 0 exponents must result in 1. Thus, a to the power of 0 is equal to 1, where a is not equal to 0. Thank you for watching.